Your heart is racing, your palms are sweating. You just read an email from your boss, and it said one word: meeting. That's it. Just meeting. But your body doesn't know that. Your body thinks you're about to die. Somewhere behind your eyes, deep in the oldest part of your brain, an alarm just went off. The same alarm. The exact same one that used to fire when your ancestors heard a growl in the grass. Back then, that alarm saved lives. Today, it just ruins your afternoon. So why hasn't it stopped? Why, after roughly 200,000 years of being human, does your nervous system still treat a Tuesday morning meeting like a predator on the savannah? The answer is far stranger than you think. Start with the alarm itself. It lives in a small, almond-shaped cluster of neurons called the amygdala. Almond in Greek is amygdale, which is where the name comes from. It's tiny, barely the size of your thumb. But it has one job, and it does that job with terrifying efficiency. Detect danger and detect it fast. Faster than you can think, faster than you can reason. The amygdala doesn't wait for your prefrontal cortex, the rational, slow-thinking part of your brain, to weigh the pros and cons. It reacts first and explains later. This is not a flaw. This is the point. In 1915, a physiologist named Walter Cannon coined a phrase you've probably heard 1,000 times without knowing where it came from: fight or flight. Cannon was studying how animals respond to threat, and he noticed something remarkable. The body doesn't deliberate. The moment danger appears, adrenaline floods the bloodstream. The heart pumps faster. Blood rushes away from digestion and toward the muscles. Pupils dilate. Non-essential functions shut down. Every resource gets redirected toward one outcome: survival. Cannon was describing a lion in the grass. He didn't know he was also describing your inbox. Here's the strange part. Your amygdala cannot tell the difference between a physical threat and a social one. To a brain built over hundreds of thousands of years on the plains of East Africa, being excluded from the group wasn't just uncomfortable. It was a death sentence. A human alone, without the tribe, without shared fire, without shared food, rarely survived a season. So your nervous system evolved to treat social threat exactly like physical threat. A public failure, a cold text message, a boss who says, "We need to talk." Your amygdala reads all of it the same way. Predator detected. Have you ever wondered why a single harsh comment can ruin your entire day, while 10 compliments barely register? That's not a personality flaw. That's 10,000 generations of ancestors who survived by paying more attention to danger than to safety. The ones who didn't were, quite simply, eaten. This is where the story gets even stranger. Because your ancestors, when they were actually chased by a lion, had something you don't have. They had resolution. Run from the lion and one of two things happens. You escape, and the threat is over. Your body burns through the stress chemicals through the physical act of running, and afterward, your system resets. Or you don't escape. And either way, the stress response completes its full cycle. It has a beginning, a middle, and an end. Your stress rarely ends like that anymore. The neuroscientist Robert Sapolsky spent decades studying this exact problem, comparing the biology of wild baboons to modern humans, and his conclusion was almost darkly comic. Zebras don't get ulcers. Zebras experience intense, spiking terror, and then it's over. They graze again within minutes. Humans, on the other hand, can sit at a desk activating the exact same stress response. Elevated cortisol, racing heart, redirected blood flow, over a conversation that hasn't even happened yet. A meeting that's still 2 days away. A message somebody hasn't even replied to. There is no lion. There is no running. There is only the alarm, ringing, with nowhere to send the energy. This is what scientists now call an evolutionary mismatch. Your biology was built for a world of immediate physical dangers with clear endings. You now live in a world of ongoing psychological pressures with no ending at all. Deadlines that recur every week. Notifications that never fully stop. Financial stress that doesn't resolve in an afternoon of running through tall grass. The alarm system is exactly the one your ancestors needed. It has simply never been updated for the world you're living in now. And your body pays for it. The researcher Bruce McEwen spent much of his career studying what happens when this alarm never really shuts off. He called it allostatic load, the cumulative wear and tear on your body from chronic activation of a system that was only ever meant to switch on briefly, then switch off completely. Elevated cortisol over months and years doesn't just feel bad. It reshapes the body. It can suppress immune function. It can